Okay, in this video I'm going to continue on with exercise 1A of the book Fundamental Applied Mathematics. We're on page 13 and the question is number 10. It reads x is a vector 5 centimeters long in a direction east 30 degrees north. Y is a vector 4 centimeters long in a southeasterly direction. Draw both vectors and draw the vector x plus y and also find the length and direction of x plus y as accurately as you can. The first thing we need to do is draw our x and y axes, making our xy plane, otherwise known as our Cartesian plane. Define our unit vectors, I hat and j hat, like so. The next thing we need to do is draw the vector x. X is equal to, the direction of x, it's not equal to, is east 30 degrees north. And the compass is like so. So what we need to do is go east and then go 30 degrees north. So this way is east and this is towards north 30 degrees, like so. Alright, the next thing I'm going to do is I'm going to resolve this vector, and I'm going to do this using trigonometry. Now, resolving vectors means the fact that this vector here is not just on the x-axis or the y, it's in both. So we need to find how much of it is in the x and how much of it is in the y. So we resolve it into its component unit vectors, which are the two vectors which when added together will create this vector. And they must be parallel to the x-axis and the y-axis. So, if I draw this vector here, which is parallel to the x, and this vector here, which is parallel to the y, by adding both those vectors, you will get the vector x. So this would be x sub, well, x again, I suppose you could say, this would be x sub y, like so. And now we need to resolve this vector. Now I'm just going to get rid of the unit vectors, we don't need those anymore, we know where they are. So, next thing we need to do is use some trigonometry. So from Sohcahtoa, that defines cosine, tangent and sine. That means sine is opposite over hypotenuse and cosine is adjacent over hypotenuse. So sine of 30 is equal to the opposite, which I'm just going to call O, over the hypotenuse, which is x, and that's the magnitude of x was equal to 5 centimeters. So this is equal to opposite over 5, therefore the opposite is equal to 5 sine of 30. Similarly, cos of 30 is equal to the adjacent over the hypotenuse, so adjacent over 5, therefore adjacent is equal to 5 cos 30. Now this adjacent is along here, it's in the I hat direction, and the opposite is in this direction, so it's in the j hat direction. And as a result you can say that x is equal to 5 cos 30 I hat plus 5 sine 30 j hat. Now an important thing here is to know why I'm able to say plus, and the reason is as follows. If you draw your xy plane again, and we define positive y that direction and positive x this direction, then up here, if it's in this quadrant, both are plus. This is negative x plus y, negative x, negative y, positive x, negative y. And if you look, our vector x is in the first quadrant, which is positive x, positive y, and for that reason we say it's positive x, positive y, as like so. So I'm just going to note this down here. Actually, what I'll do first is I'll plug this into my calculator and see exactly what that is. So, excuse me, 5 times the cos of 30 is equal to 4.3, and 5 times the sine of 30 is equal to 2.5. So x is equal to 4.3 I hat plus 2.5 j hat. Like so. Next thing we need to do is look at the vector y. Let's get rid of the vector x, we don't need that anymore. Alright, of course the unit vectors are still in the same direction. So the vector y, we're told, is a magnitude 4 and in a southeasterly direction. So southeast is this direction here, and it is at 45 degrees because southeast means halfway between south and east. So it's at 45 degrees. And this is the vector y, and whose magnitude, straight angle brackets mean magnitude, is 4. So once again we need to resolve this into its component unit vectors. the two vectors which when added together create this vector. They must be parallel to the x-axis and the y-axis. So this vector here is parallel to the x, this vector here is parallel to the y. This is y sub x, this vector is y sub y. Sub, by the way, subscript. It's in the corner, just to tell you which direction it is. So once again, applying Sohcahtoa, you find that, well, I suppose I'll do it explicitly. What's the harm? So sine of 45 is equal to the opposite over the hypotenuse, which is 4. Therefore, the opposite is equal to 4 sine 45. Similarly, cosine of 45 is equal to the adjacent over 4. Therefore, the adjacent is equal to 4 times the cos of 45. So we just plug those in. Y sub x is equal to 4 cos 45, and it's in the x direction, so we get I hat, and this is 4 sine 45, and it's in the j hat direction. The next thing we need to do is analyze what quadrant this is in. It's in the fourth quadrant where it's negative y and positive x. So for that reason we have a negative here, and that means that the vector y is equal to the following. It's equal to 4 cos 45 I hat, let's get rid of that, we don't need it anymore, minus 4 sine 45 j hat. And we know x was equal to 4.3 I hat plus 2.5 j hat. So the next thing I'm going to do is actually find out the values for 4 cos and 4 sine 45. It's 2.8, and the cos and sine of 45 are the same. So this is 2.8, and this is also 2.8. Now that, by the way, of course doesn't add to 0, because look, they're in different directions. This is in the I hat direction, this is in the j. So you can't just add them or subtract them. What you can do is add or subtract things that are facing the same direction. So in this case what we have is the vector x plus y is equal to, you add everything in the I hat direction and you add everything in the j hat direction. So it's equal to 2.8 plus 4.3 I hat plus minus 2.8 plus 2.5 j hat. Alright, so that's equal to 7.1 I hat minus 0.3 j hat. That's equal to the vector x plus y. So if we want to sketch this vector, we'll draw our xy, our Cartesian plane again. So it's positive x, negative y, so it's in this direction here. Alright, and we know that it is the vector x plus y. Now this vector is already resolved for us, we've just worked it out. So just to do that explicitly, here's the vector which along the I hat direction, here's the vector along the j hat direction. This is a magnitude 7.1, this is a magnitude of 0.3. Now I know that this says it's negative 0.3, but that just tells you its direction, and we know we've already taken into account of this by going in this quadrant. The length of this vector is 0.3. So in order to get, we'll say, the magnitude of the x plus y vector, we need to use Pythagoras. So we'll say x plus y to be squared is equal to 7.1 squared plus 0.3 to be squared. And therefore x plus y, the magnitude of x plus y is equal to square root of all that, which is approximately 7. Is that right? I'm just going to do it all the same, right? Yeah, 7.1, so it's approximately 7. So this is approximately 7 units here. The next thing we need to do is get the direction. And to get the direction, we use Sohcahtoa. So we know, for example, that you can take any sine, cosine, or tangent. I'm going to say that tan of theta is equal to the opposite over adjacent is equal to 0.3 over 7. Therefore, theta is equal to tan inverse of 0.3 over 7. And by the way, tan inverse is the same thing as saying arctangent, 0.3 over 7. I think that's approximately 53 degrees. Alright, so I'm just going to check this in my calculator here just to confirm. Nope, that was wrong. It's actually 2.5 degrees. Is that correct? Just let me check this now. Approximately due east. Yeah. Okay, so if you look, we found that this angle here is not 53. I remember that incorrectly. So it was approximately 2.4 degrees. So in actual fact, this here is 2.4 degrees. Right? So it's 2.4 degrees south of the vector east. So it's approximately due east. That's the answer that's given in the book. It's approximately due east. That's correct. So thanks for watching. Please pass it on to your friends and subscribe to my channel.